Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding the equation of a sine or cosine graph. So you will get a graph like this and you'll have to find a number of equations to fit it. In this case, we're going to find 4 equations to fit it. So whether it's a sine or cosine graph, all you need to do to find the equation is find A, B, C, and D. A and D can be found super easily from the amplitude and midline respectively. For B, remember the period is always 2 pi on B, so you can find B relatively easily. Now C is the thing that differs depending on whether it's a sine or cosine graph. C is the phase shift. So I've got a few notes here as to how you can find C. For a cosine graph, it's easy, you just find where the first peak is. If you want to find the phase shift for a sine graph, you either look for where the graph hits its midline and is increasing, or you set the peak equal to pi on 2. That's something we'll cover a bit more, and it should make more sense in a second. All right, let's take this graph here and find some sine and cosine equations that fit it. Now, regardless of whether it's a sine or cosine graph, A, B, and D will be the same. D is the midline, so that's here. I know the graph isn't drawn great, but you can find the midline as being halfway between the highest value y can take and the lowest value y can take. So halfway between 6 and -2 is +2, so D is +2. So A is the amplitude, the distance from the midline to the peak, or the distance from the midline to the nadir to the low point. In both cases, it's 4, so we have A equals 4. So to find the period, remember it's the distance between peaks. So we have a peak here at 0, x equals 0, and a peak here at x equals pi. So the distance between peaks is pi, the period's pi. Remember, B is not the period. The period is 2 pi over b. So here, 2 pi over b is the period of pi. So of course that means that b is equal to 2. So far our equation will be this. Y equals 4 sine or cos 2x plus c plus 2. All that needs to be found now is c. So let's say, for example, that this is going to be a cosine graph. So finding C is really easy because the peak of a cosine graph normally occurs at x equals 0. So all you need to do is find where the first peak occurs, take the negative of it, and that will be your value of C. Now, because the first peak happens at 0, I can have C equals 0. There's also a peak here, though, at pi. So I could also have C equals minus pi. In fact, because the period is pi, I could add any multiple of pi and not change the graph. So I could have set C equals 0, could be negative pi, it could be positive pi, 2 pi, whatever. So once you found one value of C, you can just add or subtract multiples of the period to find another value of C. So what about the value of C if it was a sine graph? This is the only thing that changes whether it's a sine or cosine graph. I can't use these for a sine graph. But if you're looking for a sine graph, look at where the midline is, but when it's increasing. So this graph hits the midline here at pi on 4. Sorry about my bad drawing. But it's hitting the midline and decreasing. So I can't use C equals negative pi on 4. But it hits the midline again here. C at x equals 3 pi on 4, it hits the midline and it's going up. So I can take the negative of that. That's what that symbol there means. So for sine, I can use C equals negative 3 pi on 4 because at this point, the graph hits its midline and is increasing. The other way you can find C using the sine graph is you can set this thing here equal to pi on 2. What am I talking about there? So the normal peak for y equals sine x occurs at x equals pi on 2. So the peak here is at 0. So what I can do to find C is I can set this thing in brackets equal to pi on 2 when x equals 0. So I could have 2x is 0 plus c equals pi on 2. That will guarantee that when I substitute x for 0, this thing will be pi on 2, the peak of a sine graph. So solving that, I just get c is pi on 2 divided by 2, which is pi on 4. That's another possible value for c. So I said before, c couldn't be negative pi on 4 because the midline, it hit the midline and was decreasing, but it absolutely can be pi on 4. So just like for cos, I can find infinitely many values of c by just simply adding the period. So if I want another value of c, I could just take pi on 4 and add pi and get c is 5 pi on 4. All of these values of c will give me a valid graph. So I've actually found 5 equations that fit the graph. I have found this one here will be y equals 4 cos 2x plus 2. When c is negative pi, I have 4 cos 2x minus pi plus 2. Or I could have y equals 4 sine 2x minus 3 pi on 4 plus 2. I could have y equals 4 sine 2x plus pi on 4 plus 2. All of these values of c can be substituted into this equation and they will give a valid equation for this graph. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.